Jai Hind to all. Myself Yogendra Prajapati, Assistant Professor at Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to teach a very important topic of the theory of automata and formal language, that is Epsilon non-deterministic finite automata. Before study the Epsilon non-deterministic finite automata, first we discuss about the non-deterministic finite automata, then start the Epsilon non-deterministic finite automata. Now, this is the formal definition of the non-deterministic finite automata. In non-deterministic finite automata, there are the main of 5 tuples: Q naught, sigma, Q capital Q, delta, and the F stand for the final state. Now, where Q is a finite set of the state, the important thing is a finite set of state. All the non-deterministic finite automata or deterministic finite automata, the set of state is finite. Sigma is a set of input symbol. It may be 0, 1 or A comma B. This is the set of input symbol. That is depend upon our question. In question, sometime given the set of input 0, 1 and sometime given A comma B. Now, the third definition of the non-deterministic finite automata, that is the Q naught. Q naught is a subset of the capital Q. It is known as the starting state or known as the initial state of the non-deterministic finite automata. Now, this one is important: transition function. Transition function of the non-deterministic finite automata, if any state Q and with the help of any input, if machine move to the Q1, then that is known as the transition function of the NFA. If the result is a single state, then that is known as the deterministic finite automata. If result is more than 2 states, then it is known as the non-deterministic finite automata. This is the main difference between the deterministic finite automata and non-deterministic finite automata. One more thing is different in deterministic finite automata and non-deterministic finite automata. DFA is a complete machine. What is the meaning of the complete machine? The meaning of the complete machine, on Q0 there must be available A-B transition if the number of input A comma B, then on every state for every input transition is available. That is known as the complete machine. It means for Q0A transition is available and for Q0B transition is available. If such kind of the transition is available, then that is known as the deterministic finite automata. But in NFA is a incomplete machine. It means on a with the respect of the input, there may be transition is available or transition is not available. Okay. Now, the last one is a common for deterministic and non-deterministic finite automata. F stand for the final state. In NFA and DFA, both are the final state. The power of DFA and NFA are same. Power of NFA and DFA are same. This statement is also important. It means every NFA can be converted into the DFA. Okay. Now, we move from the what is the epsilon. In epsilon, many times without any input, machine can move to the state, then that is known as the epsilon machine, or that is known as the epsilon NFA. And epsilon NFA first we remove the epsilon from the NFA, then NFA can be converted into the DFA. In practically, NFA are not implemented, so that every NFA can be converted into the DFA for the practical implementation. There are the some rule by which we can remove the epsilon to the NFA. Mainly 4 steps: step 1, step 2, step 3 and step 4, by which we can remove the epsilon from NFA. This step 1, find out the transition from each state from the Q. The first step, we find the transition of the NFA on each state. That will be called epsilon closure. That is known as the epsilon closure. That is the first step. We for the better understanding, we take a very simple example, then we explain all this step step by step. In step 2, then transition can be obtained delta 1 and means that epsilon closure on the epsilon move. In the second step, we find the maximum length of that particular state can move with the help of the epsilon. Now, in step 3, step 2 repeated each input symbol and each state given to the NFA, and in step 3 we repeat the step 2 until we got the final NFA, and step 4, by using the resultant status transition table equivalent NFA without alpha, and in step 4 we can draw the transition table of the NFA. We take the very simple example. Now, in this example, there are 2 epsilon are given. What is the first step? In first step, we find the epsilon closure of the each state. Now, epsilon closures. How many state? That is Q0, Q1 and Q2. By default, every state itself it is epsilon closure. It means itself Q0, Q1 and Q2 in epsilon closure. And the second step, we check with the help of epsilon what is the maximum moment of the Q naught with the help of the epsilon. It means Q naught can move with the help of epsilon to Q1. It means Q1 is also known as the epsilon closure of the Q naught. Again we check from Q naught to Q1 moment, and from Q1 to Q2 moment is also possible with the help of the epsilon, so that Q2 is also the epsilon closure of the Q naught. That point is clear. Now, Q1 by itself, Q1 is epsilon closure. Then with the help of epsilon, Q1 can move to the Q2. Now, Q2 is the epsilon closure of the Q1. Now, Q2. So, Q2 there is a no possible condition. So, only Q2 is epsilon closure of the Q2. Now, that is the step 1 and step 2. Find the epsilon closure for all the state, and that is the step 3, and next one is a step 4. We draw the transition table of the 0, 1, 2 and Q0, Q1, Q2, only Q0, Q1. Okay, now we check the transition function of the transition of 1, transition of Q0, transition of 0, 1 and Q0 transition of 2. Now, On Q0 closure, we check the transition of the 1, 2, sorry 0, 1, 2. So, what is the closure of the Q0? That is Q0, Q1 and Q2. We check the transition of the 0. And what is the Q0, Q1, Q2, we check the transition of the 2, and Q0, Q1 and Q2, we check the transition of the, that is the, find the transition of the 0, 1 and 2. Now, we check the transition of the Q0, that is Q0, Q0 no transition, Q2 have no transition. Now, we find only the resultant state is Q0. Now, here is a, what is the closure of Q0? That is Q0, Q1 and Q2. Okay. If more than 2 state, then we union of these 2 state, and that is the transition table of the NFA. Similarly, we check the transition of the, now from Q0, 1, no transition, Q1, that is Q1, and from Q2, 1, no transition, only Q1. Now, Q1, what is the closure of Q1? That is Q1 and Q2. We similarly check the transition of Q0, Q1, Q2 on the transition, now Q2, that is Q2. And what is the, now that is known as the Q2. The first step is complete. Now, we similarly, we check the transition of Q1, transition of Q2. We check the transition of Q1 on 0, it means we check the transition of Q1 closure. Similarly, we check the transition of Q2 closure. Okay. So, we follow the same step. What is the Q2 closure? That is Q1, Q2, and we check the transition of 0. And what is the Q1, Q2? We check the transition of 1, and Q1, Q2, we check the transition of the 2. Q1, Q2. Now, Q1, Q2, there is no transition is available, it means here is a phi. Here is a phi. Q1, Q2, one transition. Q1, that is Q1. For Q2, 1, no transition is available. Q1, what? Q1 and Q2. Only Q1 and the closure of Q1, Q1 and Q2. And here is Q2. Now, here is a Q2. Very simple. Similarly, we follow these steps. Now, Q2 we check the 0, Q2 we check the transition 1, and Q2 we check the transition 2. This is the phi, this is the phi, and this is the Q. Now, here is a phi, here is a phi, and here is a 2. Now, this is the complete transition table of the NFA, and we remove the epsilon, and my target is from this to convert into the NFA, DFA. Now, the second step, NFA can be converted into the DFA. So, what is the procedure? There are very simple procedure. Every NFA can be converted into the DFA. Now, this is the your NFA, and NFA, now this is the, we don't need when NFA with table has been formed, then no need to this table. Now with the help of this table we can convert NFA to DFA. Now this is the DFA and 0, 1, 2. What is the procedure to change the NFA to DFA? Start from the initial state. What is the initial state? That is Q0, Q0, Q1, Q2 and Q1, Q2 and here is a Q2. And what are the new state occur? Then new state consider as the next state. That is the method. Any NFA can be converted into the DFA. Now what is the new state? There is a Q0, Q1, Q2 is a new state, Q1, Q2 is another new state and Q2 is another new state. There is a 3 new state and these 3 new state one by one we consider as a next state, that is your initial state. Now Q0, Q1 and Q2, we check the transition on Q0, Q1, Q2 on the transition 0. Q0, Q1, Q2 the same transition is available, Q0, Q1 and Q2. Q0, Q1, Q2 on the same, that is Q1, Q2. You can check it. Now Q0, Q1 and Q2, we check the transition on 1, that is Q1, Q1, Q2, Q1, Q2, here is a 5. Thus union of these 3 states, that is known as the Q1 and Q2. Now similarly Q0, Q1, Q2 we check the transition on, that is known as the Q2. How many new state are formed? Only no new state is formed, only Q1, Q2 and Q2 is a remaining 2 state. So we consider as a Q1 and Q2 as the next state and Q2 is a next state. Now Q1 and Q2 on the 0, that is 5, 1 that is Q1 and Q2 and here is a Q2. Q2 again 5 and here is a again 5 and here is a Q2. Q2, yes. Now this is your the final result and this is known as the final target, any epsilon NFA to DFA. For the better understanding, we move for the another example. This is another example for any epsilon NFA to DFA. Procedure are the same. We follow these procedure by which we find the final outcome. Now what is the first step? The first step we find the epsilon closure for the all state. How many state? That is Q0, Q1, Q2, Q3 and Q4. Q0, Q1, Q2, Q3 and Q4. What is the state? That is epsilon closure and the rule for the epsilon closure, all state it itself at a epsilon closure, it means Q0, Q1, Q2, Q3 and Q4. By default all state itself as a epsilon closure. And the next rule for finding the epsilon closure, we check the maximum number of transition available on the particular state with the help of epsilon closure. Now Q0, with the help of we can move on Q2. Now Q2, any movement are possible with the help of epsilon, no movement is possible, only this one. Now what is the Q1? No movement is possible, no epsilon closure is possible. Now Q2, now this one is a Q2, any movement is possible with the help of epsilon, no movement is possible. Now what is the Q3? Again Q3, no movement is possible. Q4, no movement is possible. So these very simple to find the epsilon closure. Only Q naught and Q2. It is a epsilon closure. What is the next step? Find the transition table of the NFA. 0 1 0 1, and how many state? That is Q0, Q1, Q2, Q3 and Q4. We check the transition of the Q naught epsilon closure 0 1 transition. Now Q0 and Q2 we check the transition 0, that is state for Q0. Q0, Q2 we check the transition 1. Now Q0, Q2 we check the transition 0. No transition are available. Okay. Now Q2, here is a Q2. Yes. On Q2 any transition is available. Now Q3 and for 0 transition only Q3 movement is possible. So now here is a Q3. Similarly Q0 one transition is available, Q0 one transition available, that is Q1, and Q2 one transition is available, yes available, that is Q4. Then closure of Q1 and Q4, here Q1 and Q4. Target Q1 transition has been complete. Now similarly we find the Q1, Q2, Q3 and Q4 transition in same manner. Now Q1 we check the transition 0 and Q1 we check the transition 1. Now Q1, from Q1 that is Q0 and Q1 yes 1, 0 transition, no transition is available 5, and from Q1 1 transition, that is Q naught. Now here is a 5 no transition, or here is a Q0, and what is the, that is Q0 and Q2. Similarly we go for the state Q2. We next state I find the transition of the Q2. It means we check the Q2 0 transition and Q2 1 transition. Q2 0, Q3, Q2 0 no transition available. Now here is a only Q3 and Q2 1. Now Q2 1, that is Q4, and here is a Q4. Similarly we go for the next transition, that is the Q3, Q3 0 and Q3 1. Now Q3 0, that is Q2, Q3 1 no transition is available from Q3 1, that is 5. Now here is a 5 and here is a Q2 and here is a Q2, and the last one, that is Q4. Now Q4 0 transition and Q4 1 transition. Now Q4 0 transition, Q4 0, that is Q4 0 transition, that is Q2, and Q4 1 transition, no transition is available 5. Now here is a Q4, that is Q2, and here is a, that is 5. Now this is your final NFA without epsilon. And what is the next target? With the help of NFA, we can convert into the DFA, and the procedure are same. What is the procedure? Start from the initial state, and next state consider as a new state, consider as the next state. This is the procedure by which every NFA can be converted into the DFA. In previous problem, I discussed about this same procedure. Now, start from the initial state. What is the initial state? Q0, Q3, and here is a Q1 and Q4. What is the next state? New state is Q3 and new state is Q1 and Q4. So, we consider Q3 and Q3, that is Q2 and 5. What is the next state? Q1 and Q4. This one is a new state and consider as a next state. Q1 and Q4, that is Q2. Q1 and Q4, 0 transition, that is Q2. And here Q0 and Q2. What is the next state? Next state is your Q2. Q2, that is Q3 and Q4. Any new state? Yes. Q3, Q0 and Q2 is new state. Q0 and Q2 is new state, consider as the next state. So, Q0 and Q2, that is Q3, no new state. Q0 and Q2, and Q1 and Q4. Q1 and Q4. So, this is also not new state. Only one state, new state remaining, that is known as the phi. So, on phi, here is a phi and here is a phi. Now, this is known as the DFA, and my final target are achieved with the help of epsilon NFA. Final conclude the DFA are complete. For the better understanding, we take one or more example in the next lecture.